See that? It's almost 10 o'clock. I'm still here. I could have just put a video on YouTube and said, you know what? Do it. Follow along with what this person says. But you know what? I do it for you guys. I do it for the young Azizes of the world, because I am the Kobe of math teaching. I don't know. I could probably be a little bit better. But, you can try. So anyways, this is 9.8, applications of logs. Okay, the notes uses this really, really long sentence, but I'm just going to give you guys the formula. This is the investment formula. Whenever you invest money in bank, retirement, Roth IRA, 401k, 403b, all of those big fancy words you hear adults talking about, which you don't really care about right now because we just broke trying to get some Dutch. That's what this is about. Okay? I'm not even that old. I'm already putting into retirement, man. Trying to retire. I'm trying to get somewhere on the beach. Just kind of like kick back and watch soccer all day. Gotta make some sacrifices to make that happen. Anyways, the investment formula is... See, when it gets late, I get kind of loopy like this. It's A equals P times 1 plus R divided by N to the NT power. Whether or not you're going to be expected to know this formula, I'm not sure. I will let you guys know on the Friday video. So here's what it all means. A represents the amount an investment is worth. This is basically like your y of an equation. Okay? So typically you plug all of your stuff into the right side, all to get your answer A. How much is it worth? The next part you got to know is P. P stands for principal. Not your principal. Actually, it is spelled like principal. My bad. In other words, it is your initial amount. How much money you start off with. The next part is R, which stands for the interest rate. And it's really important that we put it as a decimal. We also have N, which is the number of times per year. that it is compounded. And T finally stands for the years that have gone by. T stands for time, but we measure time in years. Part A, we're going to do an example. A person invests 7 hundo and earns a yearly interest rate of 4%. I'm going to slow down, take a sip of water, stretch a little bit, text Babe while you guys catch up on the notes. Whoa, 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 whoa. Ow! Help! Owie. Okay. So, part A says, how much will the investment be worth in 10 years if it is compounded once per year? How much will the investment be worth in 10 years if it is compounded once per year? So, we have to start plugging stuff in. So, A equals P. From our formula, P stands for, let me rewrite the formula so that way we have it right here. P stands for the amount of money we invest. We invest $700. 1 plus R is our interest rate as a decimal. So if it is 4%, 4% is the same as saying 4 over 100, or 0.04. divided by n, which is how many times it is compounded. It is compounded once per year. Again, n stands for how many times it's compounded, once per year, times t, which is how much time goes by, 10 years. So we invest $700, 4% interest, once a year for 10 years. So 1 plus 0.04 divided by 1 is 0.04. 1 times 10 is 10. So using our calculators, we need to do please excuse my dear Aunt Sally to come to the end of this. So parentheses first, 1 plus 0.04. Try that again. There you go. After parentheses, it's exponents. So we're going to raise it to the 10th power. And then after exponents is multiplication, so we multiply it by our initial value of 700 to get a grand total of $1,036.17. We're going to round to 2 decimal places here because we're talking about money, and money goes to 2 decimal places. So that's how much it's worth after 10 years if we compound it yearly. So what it means to compound stuff, I think I should probably tell you guys this. To compound it, what you're doing is you're basically reinvesting it. So this is like saying after 1 year you're going to make so much money. So like so that's about how much you would make in 1 year. And then you would reinvest that. So 728 times 1.04. In 2 years, it becomes that much. And times 1.04. In 3 years, it becomes that much. So when you reinvest it, you're reinvesting that much money. Okay? And you make more of a profit every single time. So the more often you compound something, the more money you're going to make because you're getting a bigger chunk of the pie. Part B says, how much, don't run out of ink on me, how much would it be worth if compounded quarterly? In other words, 4 times per year. Okay, so you guys should have this written down by now. So we're going to put it back into this formula. So we get A equals investing $700 at 1 plus, it's still 4%, so 0.04, but now we're investing it 4 times. So instead of n being 1, n is now 4 because we're doing it 4 times per year. That's what quarters mean. Quarter means 4. 4 quarters in a dollar. So again, we can do what's in the parentheses first. So that's 0.04 divided by 4. That's 0.01. So I did that part. I still have to add 1 to it. So plus 1 makes it 1.01. So this is 700 times 1.01 to the 4 times 10, or the 40th power. So 1.01 raised to the 40th power times 700 is equal to 1,042.20 cents. So you make a little bit more money if you compound it quarterly. Okay? The bigger your investment, the more of a difference this would make. Part C, what if we took that same problem and we compounded it monthly? Every 12 months. So therefore we get A equals 700 times 1 plus 0.04 divided by 12 to the 12 times 10 power. So same problem, just the number of times is 12 now because it's monthly. There's 12 months in a year. So 0.04 divided by 12 is that number, plus 1. That's what would be in our parentheses. So 0.04 divided by 12 plus 1, that's my parentheses part right now. Now I'm going to raise it to the 12 times 10, that's 120. Raise that to the 120th power. That turns into 1.49. Then multiply it by my investment, 700, to get $1,043.58. So now we're going to talk about a new subject. This is going to be about continuous investment. So continuous investment looks like this. The amount you earn is equal to P, the principal, times E, which is a constant. E is like pi, raised to the RT power. Again, I will tell you guys if you need to know or memorize this for the test, or if I'll give it to you on Friday. You will know. Right now you have your notes. So therefore, if I were to say a person invests $500 at a rate of 2.5% compounded continuously. So part A might say, write an equation for the investment in T years. Let me slow down so you can get this all written down. So the formula A equals P is the principal, how much he invests. He invests $500, that's P. So 500 times E. R is our rate as a decimal. So it looks like it's a decimal already, but we don't want a percent. You're always going to move the decimal 2 places to the left. So this is going to be a 0.025. So this is going to be to the 0.025 T power. Part B might ask, how much is it worth in 15 years? So in 15 years, all we're going to do is plug 15 in for T. So A is equal to 500 times e to the 0.025 times 15. So in our calculator, let's do the exponent first. The number e is right above ln x. So you push second ln. Again, you push the second button, second. Then you push the ln, and that will give you e. So e to the 0.025 times 15 power is equal to that number right there. After we dealt with the exponent of e, we multiply by 500. And this turns into $727.50. So I'll show you one more time. You push second ln, and it should pop up with this on your calculator. You're going to multiply those things together, so that's 0.025 times 15, close the parentheses, hit equals, and then multiply by your initial amount. Part C might say, how long will it take to reach $700? So what it's asking us to do is work backwards. Instead of giving us the year and figuring out the money, we want the money and figure out the year. Okay, so I want to retire as early as possible because I want to still be able to enjoy my life. So I know I'm going to need a certain amount of money when I retire to live the way I want to live. So I could figure out how much time I have left if I need to reach a certain goal. Okay, and there's a formula for it and spreadsheets and computers and all that stuff, but we want to know how this works. We want to know what makes this tick. So how long does it take to reach 700? So A is 700. Our principal was 500 times E to the 0.025 times T. And we want to solve for T. So again, A is replaced by 700 because that's the amount I want to reach. P is 500, that's how much we invest. E is the constant, that is our interest rate. T is the time that we're trying to figure out. So to get E by itself, divide both sides by 500. And that will reduce 7 divided by 5. So this becomes 7 over 5 equals E to the 0.025 T. I'll go to a separate sheet of paper. So I have a feeling like this will get ugly if I kept trying to do that. So I got 7/5 equals e to the 0.025t. So I need to get this out of the exponent, which means I need some logs. So the opposite of e is ln. So this is ln of 7/5 equals ln of e to the 0.025t. ln and e will cancel each other, so they go bye-bye. So I get ln of 7/5 equals 0.025t. So therefore, to get t by itself, I need to divide both sides by 0.025. And I'm left with t equals, I'm going to change them around because I like writing the variable first, ln of 7/5 divided by 0.025. So plug this into a calculator. Again, the 7/5 is being ln'd. You do not need to subtract them. So ln of 7 divided by 5 gives us that. You could expand the log if you wanted to. ln of 7 minus ln of 5 gives you the same thing, but you don't need to. ln of 7 divided by 5 is that number. And then I still need to divide by 0.025. And I get 13.458. So if I were to round to the nearest tenths, this would come out to 13.5 years. Which makes sense, because if it took 15 years to get to 727, it would take a little bit less time for me to get to 700 even. Send me an email to bringhetto@gmail.com if you get stuck. While I'm in the car ride, I will try to answer your emails as best as possible. Yeah. Good luck. Come in Thursday at lunch for help if you need it. Otherwise, take care of yourselves. Be nice to each other. Don't be a bully. Goodbye.